This video is a continuation of the learning that we've been doing on trig ratios. And so now we've learned tangent, and then we learned sine and cosine. So now we're going to have to be able to determine which one we use. So which trig ratio do I use? I'm going to find the missing side for this triangle. First of all, I look and see what I've been given. So I can see they gave me this 32-degree angle. They gave me the side opposite that angle, and they gave me the side adjacent to that angle. So using SOHCAHTOA, I look which one is opposite and adjacent. Oh, there it is, opposite and adjacent. So I'm going to use the tangent. So I set it up. The tangent of 32 degrees is opposite over adjacent, so 28 over x. And then we use algebra to solve for x, and we get x is equal to 28 over the tangent of 32. And so if you plug that into your calculator to the nearest tenth, it is about 44.8. Let's look at another example. For this one, I have my 73 degrees. I have the hypotenuse because it's opposite my right angle. And I have adjacent. So using my little mnemonic device here, SOHCAHTOA, I have adjacent and hypotenuse, so I'm going to use cosine. The cosine of 73 is adjacent over hypotenuse, which is 50. So multiplying both sides by 50, I get that y is equal to 50 times the cosine of 73. And when you put that in your calculator, it's approximately 14.6. And we've got one more example here. This time, I again have my hypotenuse opposite my right angle, and 47 is opposite the side 32, so 32 is my opposite side. So this time I have the opposite and the hypotenuse. I'm going to use sine. So the sine of 47 would equal the opposite over the hypotenuse, which would be 32 over x. Again, I use my algebra, multiplying by x, dividing by sine 47 to get the x alone. Sine 47. So x would equal 32 divided by sine 47. And that comes out to approximately 43.8. So now we're going to start having real-world problems, situations that we're going to have to draw pictures for. And so they're going to be talking about the angle of elevation and the angle of depression in these problems. And the first thing you have to keep in mind is that the angle of elevation and the angle of depression are both relative to horizontal. We start at horizontal and move either up for elevation or down for depression. So, for example, it's a nice sunny day, and we've got a building here, and I have this guy standing down here, and he's looking up at the top of the building where his friend is. So relative to horizontal, so I'm going to draw a horizontal line, and then I'm going to draw the line, the angle looking up at his friend. And that, from horizontal to that line of sight, is the angle of elevation. And for the guy on top, again, we start with horizontal, and then he's looking down the same direction. So starting at horizontal and going down, that's the angle of depression. So really important. Always start with a horizontal line, go up for elevation, down for depression. So yes, depression something's depressed. It's down. Elevate is up. Now, one of the things you might notice is if these are both horizontal lines, this line here and this line here, then that means they're parallel to each other. And I have a transversal going through them. So if I have parallel lines cut by a transversal, I've made alternate interior angles. The angle of depression and the angle of elevation are actually alternate interior angles, and so that means that they would be congruent to each other. So the angle of elevation is congruent to the angle of depression. That's also important to remember. All right, so here's an example, and we're going to have to draw ourselves a picture because they don't give us one. So you're at the top of a roller coaster 100 feet above the ground. So you are 100 feet above the ground right there. And here's the hill that the roller coaster is going to go down. Here's my little roller coaster car. Whee, I'm having fun. Okay. All right. So the angle of depression is 44 degrees. Now this is really important. The angle of depression is not, this is not the angle of depression here. You have to draw your horizontal line. Okay, I'm going to write that. Draw the horizontal line. So I've got my horizontal line going down from there, as in depression, down. That's where the 44 degrees is. Now, because I have parallel lines, my angle of elevation is also 44 degrees. So it's really important that you draw this correctly when you do these problems. All right, so the angle of depression is 44 degrees. How far do you ride down the hill? Well, do you ride down the hill on the hypotenuse, or do you ride on the ground, or on the hypotenuse? So x is going to be right here. All right, so now I can see that I have my hypotenuse and I have the opposite. And so sine is opposite over hypotenuse, so we're going to use the sine of 44 is opposite over hypotenuse. So multiplying both sides by x and then dividing by sine 44. X is equal to 100 divided by the sine of 44. And so when you put that in your calculator, it should come out to about 144 feet. Okay, I've got one more example. This one, they gave you a picture for, so it's a lot easier once they give you a picture. The railroad crossing arm that's 20 feet long, so there's my 20-foot dimension, is stuck with an angle of elevation of 35 degrees. And so there's my 35 degrees, my angle of elevation going up. Find the lengths of x and y. Oops, upset that. Okay, so to find x is opposite, and that's my hypotenuse, and y is the adjacent. So for x, I've got opposite and hypotenuse. So for x, I'm going to use the sine of 35, and that equals x over 20. And if you multiply both sides by 20, x is going to equal 20 times the sine of 35. And so that comes out to approximately 11.5 feet. And then using, if I look at y is the adjacent, and I have the hypotenuse, so I'm going to use cosine to find y. The cosine of 35 is the adjacent over the hypotenuse, so y over 20. So multiplying both sides by 20, y is 20 times the cosine of 35. And so when you put that in your calculator, it's approximately 16.4 feet. And that concludes the video. Thank you.